Today we're going to be looking at the discriminant of the quadratic, and as we look at that sentence there up on the board, what we see since the roots of the quadratic can be found using that quadratic formula there, if a, b, and c are all rational numbers, the quantity underneath the square root, which is b squared minus 4ac, what it tells us is how many roots that we're going to get and what kinds of roots we're going to get. Because sometimes we don't need to know the answer. We just need to know how many and what kind of answer we're going to get. And so there's 4 situations that we're going to look at today. And we're going to be expected to know these. So you might want to memorize somewhere on the front of your paper. The first situation, and actually let me read the directions here, but it says, for each of the following quadratics, calculate the discriminant, its roots, and state the number and the nature of the roots, whether they're rational, irrational, or imaginary of the roots. The first situation is when the discriminant is a perfect square. And let me be more specific, because it was in writing, but I want to say it out loud. The discriminant is b squared minus 4ac. Maybe even better said, the discriminant can be found by calculating b squared minus 4ac. And the discriminant is coming from the quadratic formula. Quadratic formula has to be set equal to 0 to solve. So does the discriminant. So when we do the quadratic formula, when we do the discriminant, let's identify what we know. The fact that a is 1, the number in front of the x squared. B is 3, the number in front of the x. C is not positive 10, but negative 10. I need to include the sign there. And we're going to fill those values back in here. Our discriminant is b squared minus 4 times a times c. Well, 3 squared is 3 times 3, which is 9. And then 4 times 1 times negative 10 is negative 40. Double negative gives us a positive. 9 plus 40, 49. Once again, what I want to point out to you in this specific case is that 49 is a perfect square. That's going to be part of that is the discriminant here. Let me label as well a little bit better. 49 is the discriminant. And that's going to give us some information again about how many roots and what kind of roots we'll get. Sometimes we don't need to know what the roots are. But what we have been working on specifically this week is we've been working on quadratic formula. And the quadratic formula is right at the top of your paper there in that first sentence, so you can see it. And now what it says is, well, what are the roots of this problem? Well, it's going to be negative b plus or minus the square root of 3 squared minus 4 times 1 times negative 10, all divided by 2 times 8. The good news is we already calculated the discriminant, so we know what that value is underneath the square root. It's 49. b squared minus 4ac, I'm pointing to the value underneath the radical. When we go back here to the far left, b squared, 3 squared minus 4 times 1 times negative 10. Same value there in both places. Well, it's negative 3 plus or minus the square root of 49 over 2. Can we take the square root of 49? It's 7. We can take the square root of 49. We get negative 3 plus or minus 7 divided by 2. And ultimately what we're trying to figure out is what are our roots, our x-intercepts, our zeros, our solutions to this function in this particular part. And we can type this into our calculator if we need to. With the fraction button, it's alpha y equals, and it's -3 plus 7 divided by 2. If you don't have a fraction button, it's parentheses. I'll do the other root. -3 minus 7, close the parentheses, divided by 2. Our roots in this particular case are 2 and -5. And the discriminant, and how many and what kind of roots go together. So before we even talk about the number and the nature of the roots, could we have factored this equation? And what we said yesterday is that our answers here, do they have a square root in them? No. Do they have an imaginary in them? No. And because they don't, that means that we can factor. And again, the discriminant and how many and what kind of roots are the number and the nature of the roots. What happens is when we use the quadratic formula, we see that we have 2 roots. And because there is not a square root and there is not an imaginary in there, these are called rational roots. The technical definition of rational is any number that can be written as a fraction. Again, I'll say that one more time. I'm not going to write it down, but any number that can be written as a fraction. It doesn't have to be written as a fraction, but it can be. Once again, perfect square. If we get the perfect square for a discriminant, we get 2 rational solutions. And you may see sometimes 2 real rationals. So I'm going to leave it at that. That's our first situation. Our second case is when the discriminant, b squared minus 4ac, that's the discriminant, is not a perfect square. And luckily our equation is already set equal to 0, and we can identify that a is 1, b is -6, and c is 7. We fill in the quadratic formula, we fill in the discriminant. We get our discriminant equals -6 squared minus 4 times 1 times 7. If you're typing this into your calculator, you have to have parentheses around the -6. Because -6 squared is 36, not -36. It's -6 times -6. 4 times 1 times 7 is 28. And 36 minus 28 is 8. That's our discriminant. And again, this is not a perfect square. It's up there at the top of the situation, but just to label it a little bit more specifically. Well, now that we've determined that, let's look and see what kind of roots are we going to get. So we fill in the quadratic formula. -b plus or minus the square root of b squared minus 4 times a times c, which should look familiar to us, all divided by 2 times a. And I'm squeezing it in, and you probably are too. But when we simplify this a little bit more, negative and a -6 gives us +6. Some of you just wrote +6 already. Plus or minus, we already know what this value is. The value underneath the square root is the discriminant. And then it's going to be divided by 2 times 1, which is 2. We can simplify this a little bit more. We've got the square root. We always look to see if we can simplify it. And 8 is 4 times 2, which ultimately gives us 8 is 2 times 2 times 2. And maybe you want to write it like this. 2 times 2 times 2. And what we need is we need 2 of the same value to take out 1. 2 of the same value to take out 1. That means when we simplify a little bit more here, we get 6 plus or minus 2 radical 2, all divided by 2. Well, finally here, that is a good answer, but it's not the best answer. Because 6 is an even number. And the 2 in front of the square root is an even number. And the denominator, the bottom of the fraction, is an even number. We can divide all of these by 2. Because they're all even numbers. 6 divided by 2 is 3. 2 divided by 2 is 1. 2 divided by 2 is 1. No, you don't have to write the ones. But you, like me, are probably running out of space at this point. But you can write 3 plus or minus the square root of 2, which are the answers, the roots, the solutions, the x-intercepts to this function. The answer is 3 plus or minus. That means that we're going to get 2 solutions. But this time we get radicals as part of our answer. So can we factor this? When we get a radical, a square root, we can't factor. And what happens is that a radical is also called an irrational value. So we get 2 irrationals, and if I couldn't fit my S on there. Oftentimes it says 2 real irrationals. The definition of an irrational number is a non-repeating, I always say a non-repeating infinite decimal. A non-repeating, non-terminating decimal. I oftentimes refer to them as big long decimals on your calculator. 2 irrationals, again, when our discriminant is not a perfect square. 2 more situations here. The third one is when the discriminant equals 0. We go back up here. A is 1. B is negative 10. C is 25. We're going to fill these values into our discriminant. And we end up with negative 10 squared. Again, if you're typing this into the calculator, you have to have the negative 10 in parentheses. Minus 4 times A times C. Negative 10 squared is negative 10 times negative 10, which is positive 100. 4 times 1 times 25 is 100. And when we subtract 100 from 100, it's 0. There's the discriminant. Well, let's look, because what we're trying to decide is, well, once we know that number, what does that tell us about how many answers we're going to get and how many, or what kind of answers we're going to get, the number and the nature of the roots. I'm going to make the quadratic formula a little bit simpler, but it's going to be negative, or the opposite of B, negative and negative 10, plus or minus the square root of 0. Do we really need to write it all out when we just wrote it? Now, there's nothing wrong with writing it out. B squared minus 4AC, putting it in there. But we already know the value. Divided by 2 times A. And that way you won't have to cram everything in on your paper. What's the square root of 0? It's 0. So this is just negative and a negative, which gives us positive 10. 2 times 1 is 2, and 10 divided by 2 is 5. Once again, we're looking at this situation when the discriminant equals 0. We only get 5 for our answer. That's 1 root. If we get 5, can we factor this equation? Does 5 have a radical in it? Nope. Does 5 have an imaginary in it? Can we factor it? Yes. We can factor. And just like case A, this is considered to be a rational. Definition of rational. Any number that can be written as a fraction. Doesn't have to be written as it, but it can be. And 5 can be. Our fourth situation is when the discriminant is less than 0. What does less than 0 mean? I think somebody said it. Let me change colors here so it blends in there a little bit. It means that our discriminant is going to be a negative value this time. Nice part on our equation that we're given is that A is 1, and B is negative 8, and C is 20. It's already set equal to 0. We can fill in the discriminant. Be careful with the B if you're typing it in. We get negative 8 quantity squared minus 4 times 1 times 20, which gives us 64 minus 80. I don't know what I was thinking there. 64 minus 80, 4 times 1 times 20. And 64 minus 80 is negative 16. The discriminant is less than 0. It's negative. Well, let's look. What kind of answers do we get when we're working with the discriminant less than 0? Try to keep it a little bit simple again. The opposite of B. Plus or minus the square root of negative 16. We just found that value. There's no reason to write it again. Divided by 2 times A. Well, negative and negative gives us positive 8. Plus or minus, well, what's the square root of negative 1? And can we take the square root of 16? So we're going to get plus or minus 4i divided by 2. Again, it's a legitimate answer, but we can make it better. 8 and 4 and 2 are all even numbers. 8 divided by 2 is 4. Plus or minus 4i, 4i divided by 2 is 2i. 2 divided by 2 is 1. We don't need to write the 1. I'm fine if you decide to. But when we simplify that, we get 4 plus or minus 2i. Can we factor this expression when we get an I for an answer? No. We cannot factor it. How many answers did we get? We got 2. Plus and minus. There's the 2. And this time, since they are, trying to fit that all in there, imaginary, I'm going to write that same word. I just try to put it in there. I-M-A-G-I-N-A-R-Y. And I know I wrote singular when, if you want to get technical, there's two imaginary numbers. Sometimes what they say is that they're 2 unreal answers. The thing is, what happens when we get an imaginary answer? Well, if we flip our paper over, what happens when we get an imaginary answer is that we don't have any x-intercepts. Our graph doesn't cross the x-axis. That's why we get an imaginary. But as we look at this back page here, and I'll try not to go too fast, but I'm going to go faster than I would like. By using only the discriminant, determine the number and the nature of the roots of each of the following. Then sketch the function on the grid provided. I have the sketches in here. You may need to go back and fill them in later. I'll try to show them, but we're on limited time here. And that's something that you can type in your calculator to get the sketch on. The first one, when we look at this problem, is A is 2, B is 7, and C is -4. We want to find the discriminant, and then we want to know how many and what kind of roots. Not what the answer is, but if we fill in B squared minus 4 is C, 7 squared minus 4 times 2 times -4, we get 49 minus 4 times 2 is 8 times -4 is -32. And 49 minus the -32 is plus 32, gives us 81. Well, is 81 a perfect square? 81 is a perfect square. And we don't really need to write that, but I just want to remind ourselves, since 81 is a perfect square, how many answers are we going to get? 2. And is it going to be rational or irrational? Because it's a perfect square there, it's going to be rational. Question? Yep. Here's the picture. Again, I would prefer to get through our last examples rather than spending our time drawing the pictures. But you can go back and type these into your calculators. If you are writing really quickly, this is 0.5, 0 on the root to the right in a graph. But you can find that on your calculator yourself. We're going to spend the time on discriminant here, but that's a picture to go with our words. If we look at letter B, I highly recommend that you label the problem. A is 1, B is -8, C is 25, and we're going to fill in the discriminant. B squared minus 4 is C. -8 squared minus 4 times 1 times 25. Well, -8 squared is 64. And 4 times 1 times 25 is 100, which gives our discriminant as -36. How many answers are we going to get? We're going to get 2. And this one is negative. I draw my arrow here to the negative. It's going to be a negative. What kind, then, are those going to be? It's going to be imaginary. Overall, I think that these are fairly easy to remember. The hardest part is imaginary and irrational, because they both start with I. The picture, again, not my primary focus here, but notice that the picture does not cross the x-axis. It doesn't. And that's what happens when we get an imaginary root. So if you're sketching, sketch really quick. Or pause the video and come back and fill it in. Letter C, finding the discriminant. Well, we've got A is 4, B is 4, C is 1. When we fill in our discriminant, then B squared minus 4 is C, it's going to be 4 squared minus 4 times 4 times 1, which is 16 minus 16 gives us our discriminant equals 0. how many answers do we get when the discriminant's 0? And there's nothing wrong with you turning your paper over and looking at the answer. And then, is the answer going to be rational or irrational? It's going to be rational. The picture here only touches the x-axis. Most of the problems that we've done so far have crossed the x-axis, or not. But this one touches it. It's at negative 0.5, which doesn't show up very well probably to the people in the back. But again, that's something that you can type in, and it'll give you a chance to practice your solid by graphing skills. When we look at letter D, A is 4 again, B is negative 4, and C is negative 7. Again with the discriminant, just like the quadratic formula, has to be set equal to 0. We fill in b squared minus 4ac. Negative 4 squared. You need parentheses if you're using your calculator. Minus 4 times a times c. And we end up with 16 minus a negative 112. But double negative gives us a positive. And when we add that together, 128 for our discriminant. How many answers are we going to get? Well, 3/4 chance there, 75% chance right. 3 out of the 4 give you 2. There's only one situation where you get one answer. 2. Are these going to be rational or irrational? It's going to be irrational. We cannot take 128 is not a perfect square. It either is or it isn't.
Well, why is it?
Picture is here. Again, something that you might need to type in and get the answers there. But our graph does cross the x-axis twice. And as we finish, a good exam question. Which of the following discriminants belongs to the parabola with 2 rational x-intercepts? It's going to be the perfect square. 8. When the discriminant's 8, it's going to give us 2 irrational. When the discriminant is 0, we're going to get 1 rational. When the discriminant is negative 5, we're going to get 2 imaginary. It's our perfect square choice that gives us the 2 rational x-intercepts.